So we're going to solve this system of equations using substitution. Now this is a purely by hand method. I could use the CAS, I could use graphically, but I am using this purely by hand method just to have a little bit of a different approach that can help with some of the theory. So the first thing I'm going to do, just kind of for convention's sake, is label each of the equations. Okay? So I'm going to call that first equation equation A and the second one equation B. Again, that doesn't change anything mathematically, it's just so I can refer to them more easily versus having to say the whole equation. Now we're going to get into what the question's asking us to do using substitution. So I'm going to substitute equation A into equation B, meaning I'm going to start with equation B, and now I want to do this thing called substitution. So I've got two equations with two unknowns. I would much prefer to have one equation with one unknown. So what I'm going to do is take equation A and replace the value for y in equation B. So because y is equal to both of these statements, well, that means that these two statements have to be equal. So if I take this part of equation A, I can pop that in for y in equation B, just like this. So I end up with 3x plus 4 is equal to negative 2x plus 9. That's because y by definition is equal to y, so I can substitute that in. Now that I have one equation in one unknown, now I'm going to go through and solve for x in my new equation. So I have this. Take a moment and see if you can isolate x. Okay, so the first thing I want to do when I'm isolating x is make sure I just have one x in the equation, so moving all of the variables to one side. So I'm going to start by adding 2x on both sides. Because negative 2x plus 2x, well, that just becomes 0. So I end up with 5x plus 4 is equal to 9. And then I want all the numbers on one side, so I'm going to subtract 4 from both sides to give me that 5x is equal to 5. And then finally dividing by 5 to get that x is equal to 1. Okay. So now I know one of the coordinates of the point. So when those two equations are equal, it's when the x coordinate is equal to 1. Well, what's the corresponding y coordinate? Now this is going back lesson 1. We're going to substitute the known value into equation A. Doesn't really matter. Equation A is first, so I can plug into that one. So there's equation A, but x is equal to 1. Sorry, meaning that I can replace this x with a 1 to give me that y is equal to 7. So once you get these two values, you need to clearly state your conclusion. So therefore the solution is 1, 7, because it's always x followed by y. I can do this final step, which is checking in both equations. So if I put 7 in for y and 1 in for x, I get that 7 is equal to 7 for equation A, so that one's all good. If I put 7 in for y and 1 in for x in equation B, I also get 7 is equal to 7. So that did work. If those two values weren't equal at the end, then something has gone wrong. So that's how I can solve using substitution. Again, it's a bit of a funny example when they're already isolated, but if they're not, then you just need to isolate them to start.